Imagine an AI where you can just prompt it to find a cure for a rare type of cancer, and it would design an entire experiment and execute it, and through logic and reasoning actually come up with a viable, verified solution. This AI can be used for a ton of new scientific discoveries, such as finding new materials or finding cures for dementia and diabetes and other diseases. This can also be used to solve math and physics problems that no humans are able to solve yet, and this could help us expand our understanding of the universe. Well, Google seems to be working on this right now. Recently, Google released this blog. AI achieves silver medal standard solving international mathematical Olympiad problems. Plus, Demis Hassabis, head of Google DeepMind, also tweeted this. Now, this was just a simple blog and simple tweet. There was no fancy marketing event and no fluff. But the implications of this are massive. We can expect huge breakthroughs in science and math, plus this might even be the key to super intelligence. So today we're going to go over what exactly Google is planning and why this is such a big deal. So let's dive right in. Now, throughout the past few months, in terms of their performance of AI language models, Google has been slightly behind other AI companies like OpenAI and Anthropic. So if you look at this LMSys leaderboard, which ranks AI models based on user blind tests, you can see that Google's flagship model Gemini is behind GPT-4o and Claude 3.5 Sonnet. Now, this is surprising since Google owns the biggest search engine in the world, and therefore pretty much all the public data on the internet. They also own Android and Gmail and Google Workspace and Google Analytics. So some would argue that they have access to the biggest amount of user data in the world. And as we know, the more data you have, the more intelligence of an AI model you can train. So it's strange that they don't have one of the leading AI models out there, at least in terms of large language models. Well, it turns out they are creating something completely different. This isn't just focused on chatting, but this is a beast that could potentially blow existing AI models like GPT and Claude out of the water. So recently, Demis Hassabis tweeted this. We have long pioneered the use of these types of neurosymbolic systems, starting with AlphaGo in 2016 through to AlphaZero. We will be bringing all the goodness of AlphaProof and AlphaGeometry 2 to our mainstream Gemini models very soon. Watch this space. So just a really short and simple tweet, but this is actually huge. And we're already seeing some results of it. So fast forward to today, if you look at this leaderboard, for the first time ever, Google's Gemini 1.5 Pro is now the top model out there. And note that this is just 1.5. This isn't even 2 yet. So let's go over what exactly are AlphaProof and AlphaGeometry 2. These are two advanced AI systems developed by Google to solve very complex math problems. Now, this video is much more than just talking about solving math problems, and I'm going to go over the implications of this in a second. But first, here are some impressive things that these two systems were able to achieve. So AlphaProof, along with AlphaGeometry 2, scored 28 out of 42 points at this year's International Mathematical Olympiad. They also earned a perfect score on each problem solved. And so this is equivalent to a silver medal status. And by the way, the gold medal threshold this year is 29 points. So it was just 1 point away from achieving gold medal. Now, this might not seem like much, but here's why it's a huge deal. The International Math Olympiad is the most challenging and most prestigious math competition in the world for high school students. And heck, even most adults cannot solve these problems. Think of it as like an Olympics, but for math. In fact, each country can only send up to 6 students to participate. So these are like the smartest of the smartest students in the world. The problems at this competition are incredibly difficult and require deep understanding and critical thinking. They go way beyond typical high school math and into advanced topics that most people have never learned before. They often involve advanced concepts from things like number theory, algebra, geometry, and combinatorics. And these topics require deep understanding and are designed to test problem solving and creative thinking. In fact, being able to participate in the International Math Olympiad is already difficult enough. Each country typically selects its team through rigorous national competition, so you literally have to be a genius among geniuses and win a ton of national competitions in order to make the team. And doing well in the Olympiad often requires years of dedicated practice. Many participants go through extensive training camps and actually work with coaches to hone their math skills, just like how a regular Olympian would train for years and years. Now, during the competition, participants try to solve 6 problems over 2 days. This might not seem like much, right? It's only 6 problems, plus they have 2 days to solve it. But actually, a lot of these problems require a ton of deep thinking. So 2 days is actually quite a limited time to solve these 6 problems. In fact, many of these questions often involve abstract concepts, so even understanding the problem itself can be a challenge for us regular people, let alone finding the answer. I mean, here are some examples. Let n and k be 2 integers with n greater than k, which is greater or equal to 1. There are 2n plus 1 students standing in a circle. Each student S has 2k neighbors, namely the k students closest to I don't even know what I'm reading here. I mean, I don't know about you, but after reading these questions, I suddenly feel a few levels dumber than I already am. Like, I have no clue what's going on here. So anyways, back to Google's AlphaProof and AlphaGeometry 2. They successfully solved 4 out of the 6 problems in this year's competition, including 2 algebra problems and 1 number theory problem and 1 geometry problem. Notably, AlphaProof solved the hardest problem in the competition, which was only solved by 5 contestants. Another crazy thing is AlphaGeometry 2 solved this year's geometry problem within 19 seconds. Again, note that this is one of the hardest math problems in the world, and it requires a lot of deep thinking and logical reasoning. So usually it would take a really smart human hours or days to solve this, but AlphaGeometry 2 just crushed this in 19 seconds. And then for the rest of the questions, they said that the AI took within minutes to up to 3 days to solve. And this is another interesting point to note. It can take 3 days to solve a problem instead of just trying to answer it immediately, which is what we see with current AI models. I'll talk about why this is so important in creating superintelligence in a second. So here we have an AI that can think for a long time and do deep logical reasoning and come up with an optimal solution. It can solve some of the world's hardest problems. Now, this goes beyond just solving math and geometry problems. This is actually a lot more groundbreaking than that. But before we go into the implications of this, let's actually look at how AlphaProof and AlphaGeometry work. So let's start with AlphaProof. AlphaProof is actually a combination of 2 key technologies. The first piece is Gemini, which is Google's large language model. This is similar to GPT or Claude, so it basically understands natural language and you could talk with it like a regular chatbot. The second piece to this is AlphaZero. This is an AI system that has crushed the best human players in the world in strategic games such as chess and Go. So really quickly, here's some info on AlphaZero and how it can beat the best human players in the world. This is another AI designed by Google, which learns to play games like chess and Go through a process called self-play. AlphaZero starts with no prior knowledge of the game except for just the basic rules. It doesn't even learn from human games or strategies. But what it does is it plays millions of games against itself. This is like having a super fast player who plays millions of games in a short amount of time. And every time it plays, it learns and improves. This is called reinforcement learning. AlphaZero also uses a technique called Monte Carlo tree search to plan its moves. It tries to think through or simulate many different moves into the future and try to find the best move to take right now. As it plays, AlphaGo remembers what worked well and what didn't. It adjusts its strategies based on the outcomes of its games, similar to how a human might learn from their mistakes. So over time, it develops its own strategies and a kind of intuition for how to play the game well. And because AlphaGo learns entirely through self-play, it can discover new strategies that humans have never thought of before. And this has led to some very surprising results. Now, the crazy thing is AlphaGo is able to generalize across different games. It's not limited to Go, for example. It can also crush chess and other games using the same learning process, and it doesn't need to be reprogrammed for each new game. So anyways, that was quite a tangent, but back to AlphaProof. It basically combines a natural language model, Gemini, with AlphaZero. Now, you might be wondering, why? Why did they have to combine these two? Well, here's how it works. When you give it a math problem, it first uses the natural language model Gemini to interpret that problem into a mathematical language called Lean. It then uses AlphaZero to come up with a ton of different ideas to see which ones can solve the problem. Again, this is using something called Monte Carlo tree search, where it basically looks at all possible scenarios in a chess game, for example, before deciding on the best move to take next, and then it does the same for the next step. So this is very similar, but instead of chess, this algorithm is now coming up with a ton of ideas on how to potentially solve this problem, and then rigorously testing each one. Thanks to the sponsor of this video, Vidu. Vidu is a state-of-the-art AI video generator capable of generating videos in various cinematic styles, including animation, science fiction, mystery, fantasy, romance, and more. You can easily create videos using text prompts. For example, here's a lone fairy guiding you through a glistening meadow as she leads you to a secret waterfall. Here's a cargo ship in a calm lake during sunset. And here's a majestic lion surrounded by swirling smoke. You can also select animation style and choose the duration of the video. Plus, you can upload an image and turn that into a video as well. This is a great way to generate videos with consistent characters. You can also upscale videos to up to 1080p resolution. Vidu is a super versatile and easy to use platform to generate videos of whatever you imagine. Try it out for free via the link in the description below. And then over time, after feeding this AI with millions of math questions and a lot of trial and error, it would get better and better at understanding complex math problems through reinforcement learning, to the point where it can now solve some of the hardest math problems in the world. The key thing to understand here is that AlphaProof doesn't just use pre-programmed solutions. It actually learns how to approach and solve math problems, much like a human would. But of course, it can process information and try solutions way faster than any human can. And we don't see anything like this in the current state-of-the-art models like GPT-4o or Claude or Llama yet. So that's a quick overview of AlphaProof. Next, let's look at AlphaGeometry 2 as well. So this is an AI that can solve very complex geometry problems, and its design is also quite similar to AlphaProof. So it uses a neuro-symbolic hybrid system combining a natural language model, again based on Gemini, and this is capable of understanding natural language. So this is the neuro part. Gemini and all these other AI models that you and I know today, these are good at pattern recognition. So it's used for things like image and object recognition and also natural language processing, as you've seen with ChatGPT. It's fast and reflexive, but it doesn't think deeply and strategically. The other component is a symbolic engine, and this is good at logical reasoning. It's used for things that require step-by-step problem solving, such as planning and deduction. It's much slower and more deliberate, and it thinks more deeply. And so this is the component that provides the logic and reasoning to AlphaGeometry. So when you give it a math problem like this, here's how it works. The neural component basically interprets the question and then provides a ton of likely solutions to the problem. Again, it's like predicting all the possible next steps in a chess game. Some of these, and probably most of these ideas, would not solve the problem, but it just comes up with a ton of these ideas to try out. And then this symbolic engine part, this is the component that actually takes these ideas and through its deductions and deep reasoning helps the AI close in on the solution. And for AlphaGeometry 2, they also added this new knowledge sharing mechanism, which is used to enable advanced combinations of different search trees to tackle more complex problems. So it's like combining multiple search trees together to figure out a problem more efficiently. So again, this is mentioning this Monte Carlo tree search, where it can search through all possible ideas to solve a problem, and then decide on the best move forward. And so for AlphaGeometry, you feed it with millions and millions of these geometry problems, and it learns iteratively through its mistakes and successes along the way, until finally we now have this super smart AI that can solve Olympiad level questions. So in a nutshell, that's how AlphaProof and AlphaGeometry work. Now again, this video isn't just about solving math and geometry problems. It's much more than that. What Google is working on could lead to a super intelligent AI, much more intelligent than the models that you and I use today. But before we talk about this, first let's look at the limitations of current AI models. First of all, current large language models like GPT or Claude or Gemini don't actually think. In other words, they don't actually pause and think about how to best answer the question. Once you prompted something, it just immediately starts generating an answer for you. It's fast and reflexive. But that's not really how us humans respond to information. Once we receive some input, we often need to process it and think about what would be the best action to take or the best response. This is especially relevant for planning and strategic thinking. And current large language models lack this ability. So if we want to achieve higher intelligence, we need to give it this ability to think more deeply and not just spit out an answer immediately. Current AI models also lack the ability to self-check or verify its answers. Once it starts generating something, it'll keep going even if it might be on the wrong track. It doesn't pause to check if its response is indeed correct, and if not, it also doesn't automatically correct itself. So here's an example. In ChatGPT, I'm going to ask it to give me a description of Stable Diffusion 5. And you can see that it goes on and gives me a made-up description of Stable Diffusion 5. There is no Stable Diffusion 5. This does not exist. But it just spits out an answer, and it doesn't actually fact check and verify if this is correct or not. And here's another limitation of current AI models. They might not have a deep contextual understanding of scientific concepts or the world around them. They operate based on patterns in their training data rather than true understanding. So they'll do very well if you ask it a question about something it has seen in its training data, but it usually fails to adapt to new scenarios and will hallucinate wildly. It's the same with this example. If I ask it about Stable Diffusion 5, which it has not seen in its training data because this doesn't even exist, then it just gives me a made-up answer. And because of this, current AI models are not very useful in terms of scientific research or discovering new things. And this brings us to another related limitation. Current models lack true novelty or originality. Yes, it's able to give us impressive results by combining or transforming existing information from the training data, but it lacks true creativity. In other words, its outputs are constrained by the data it has been trained on, but it can't create genuinely new concepts or ideas. And because of this, it kind of lacks the creative thinking which is often needed to solve very difficult problems or make scientific breakthroughs. Now, back to Google, here's why this is such a big deal. So they've announced that they will bring the goodness of AlphaProof and AlphaGeometry 2 to their mainstream Gemini models very soon. Now, Gemini is this basic language model, very similar to ChatGPT. But now if you combine the superpowers of AlphaProof and AlphaGeometry into Gemini, here's what happens. You get an AI model that can actually think deeply. It doesn't just blurt out an answer immediately, but maybe through Monte Carlo tree search, it actually generates a ton of different answers, and then through logic and reasoning, it chooses the best answer to give you. And because of reinforcement learning, it can learn iteratively, just like how it can get better and better with each game of chess it plays. This is an AI that can potentially get smarter and smarter over time. And it also actually self-checks its answers and proves that it works. So you're not going to get any hallucinations or made-up answers like you do with current AI models. This is especially important when you're dealing with science and medicine, because obviously you don't want it to hallucinate and give you a completely made up answer. You want to be certain that the solution actually works. And because they're mixing this with Gemini, it's like having an English professor and a math genius working together to solve very complex problems. So perhaps one day you can just prompt it to find a discovery for a certain type of cancer, for example, and then through step-by-step reasoning, it would proceed to understand the problem and do some initial research, and then design a ton of experiments and test out a ton of different ideas, and then using Monte Carlo tree search find the optimum solution to the problem, and then keep iterating every step of the way until it reaches a final solution. This is an AI that can tackle complex math and science problems just like how humans would methodically do scientific research. This AI doesn't answer you instantly, but instead might take hours to days or even weeks of deep thinking to come up with the best solution. And we can be sure that the solution works because through the process, it will rigorously test and verify its answers to prove that it actually works. By the way, Yann LeCun, who is chief AI scientist at Meta, he doesn't have much faith in current large language models. He argues that these models don't possess an understanding of the physical world. Specifically, he pointed out that they lack basic spatial reasoning. For example, he claims that these models can't recognize the position of objects or navigate physical spaces. Well, that aged pretty quickly because now if you merge Gemini with AlphaGeometry 2, well, it can now understand and solve problems involving movements of objects and complex geometric relationships. This goes beyond text processing to actual spatial reasoning. And this isn't just basic spatial reasoning, but spatial understanding at the Olympiad level. Far better than what most humans can even understand. So bringing this all back to this blog and this tweet, it seems that Google is brewing something big here. While the other leading AI companies are just focused on building these large language models, and yes, they're doing great in terms of basic chatting and coding, Google is working on algorithms that require a lot more deeper thinking and reasoning. And right now they already have these AI systems that can solve the world's hardest math and geometry problems. And now Demis is announcing that they will integrate these superpowers into Gemini. And once that happens, I really think it's going to blow these other competitors out of the water. And we're already seeing some signs of this right now with the latest release of their Gemini 1.5 Pro. Right now, this is the #1 AI model out there, as ranked with blind tests from other users. This is a huge leap forward by Google. And this isn't even Gemini 2 yet. I think once we get to version 2, this might be a super intelligent model that can think deeply and verify its answers and get smarter with time. Think how useful this would be for like strategic planning of a business or making scientific discoveries. The sky's the limit here. Anyways, that sums up this video. Let me know in the comments what you think of all of this. And do you think, merging these two technologies with an LLM is the key to super intelligence? Once this has been accomplished, could we just sit back and relax while we let AI do hard science and math and help expand our understanding of the universe? I'd love to hear your thoughts, so let me know in the comments below. As always, I will be on the lookout for the top AI news and tools to share with you. So if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.